everyone. Welcome to another MEF webinar. The title of today's session is the role of machine learning in enterprise communications. I'm Tim Green. I'm the features editor of MEF, and I'll be hosting the session today. And I'm delighted to be joined in Seattle by Surash Patel, General Manager of Messaging at RealNetworks, and Chris Galdun, who's VP of Messaging Solutions at Syniverse. We asked them to get a room, and they've got a room. And it's in front of the Seattle Mariners Stadium. So they'll be, when we finish discussing messaging, they might do a bit of sports punditry for us, you never know. Anyway, we've got about 40 minutes to discuss this topic today, but before we do, some brief housekeeping. If you want to ask a question, and I urge you to do that, you can click on the Q&A button at the bottom of your screen, and we'll see those questions, and we'll come to those at the end of the session. We'll make this recording available on MEF channels, social channels, and on the MEF website. And if you've registered today, you'll get an email alerting you to when that becomes available. We're also going to be showing a few slides today, and those slides will be made available to you to share as well at some later point. So with that done, let's kick on with the discussion. So obviously everyone's kind of obsessed with machine learning. It's a big topic now. It's the technology that's letting police forces all over the world spy on us and so on. But it has other uses. But before we get into how it's changing the world of mobile messaging, maybe we can just kick off with a kind of catch up on where we're at with business messaging at the moment. So Surash, maybe I can turn to you and you can sort of give us a bit of an insight into where we're at with enterprise messaging.
Sure. So if we think about enterprise messaging today, why is it such a critical communications tool? We still have this idea of ubiquity. Everyone has a SMS inbox, and it's been a fantastic way of supporting the consumer. We have a slide to demonstrate this, the consumer adoption curve. And what you see on this is something I've used quite a lot, just to show the propensity for consumers to adopt new technology. In the early days there, you see on the left-hand side how long it took for the telephone to become 100% adopted. But then you looked right the way through to 2010, you see that things like tablets, the curve is very, very, very steep. And that tells us that these days consumers are very, very receptive to new technologies. And when you have a technology like SMS, which is so ubiquitous, 98% open rate, we all know the statistics, right? We're also finding that as brands want to engage with their customers, they have to come up with more compelling customer journeys. And SMS has really been a tool that's helped with that. If we think, a few years ago, we weren't used to doing two-factor authentication, but now it's something that we use virtually on every business that we work with. So yeah, it's that sense that SMS has become a universal tool, but a very, very versatile tool.
So given that enterprise messaging is pretty much ubiquitous now, there are clearly some challenges in that space. Again, maybe you can just elaborate on the challenges around, business models and fraud, grey routes, and so on.
Mm-hmm, mm-hmm. So if we think about some of the challenges, we all know the challenges. There's kind of two levels to the challenges, and we'll think about the audience on this call. From the mobile operator perspective, as you mentioned there, Tim, there's that idea of fraud, where the mobile operators are being defrauded because traffic is going along on things like grey routes, or there's SIM farms, and there's all these ways that fraudsters and malicious actors are trying to defraud the operator. And I think there was a survey from MEF last year where we talked about the numbers being about $1.5 billion being defrauded that the mobile operators alone were thinking about. But if we think then to the consumer level, what does that mean for the consumer? From the consumer's perspective, that number could be 2 or 3 times higher because of the inconvenience and some of the fraudulent activities that really affect the consumers these days. And if I roll back to that consumer adoption curve, what happens there is as we become more receptive to more sophisticated customer journeys, and brands try to do more sophisticated customer journeys using SMS, then the opportunities for fraudsters increases as they start to use more elaborate tools. And that's when you have the impact of spoofing and smishing, trying to trick the consumer in ways that they might not be receptive to. So yeah, I think these are some of the challenges that we're facing in the market today with regards to messaging.
So those are kind of consumer level frauds. What about more organized kind of, fraud that's really just enterprises doing, shortcutting the system in order to, get better deals or not pay at all?
Oh, so a more sophisticated fraud. Again, from a perspective of things like sim farms, it's more organized companies thinking very maliciously about defrauding the operators. And we've seen things where the fraudsters will move internationally and set up in other countries because they know that they're able to send messages from another country locally. And we've seen things like messages, A2P messages being sent on what should be domestic routes for this kind of traffic. So the fraudsters, I think, I guess on two levels. One is if they're able to sell these messages, then the rewards are great. And also from the consumer fraud perspective, the rewards are getting greater as well.
And what have been the traditional approaches to combating these kinds of fraud, both kind of operational and technical?
So I think from a technical perspective, I think one of them, there's been lots of technology around filters and firewalls. And when we look at this kind of stuff, it's actually looking at the technical flow, the communications layer, if you will, the IP addresses being used, and analyzing messages from that perspective. And if you think about how we've seen that market grow up, we've seen more and more work being done at that technical level, thinking about how to program some of these things. And what we find is that these things tend to be quite reactive to spotting events after they've occurred and then doing something about it, and then reprogramming the technology accordingly. And that's as we've entered the market with our propositions, that's typically what we've seen happen. It's been a very, very technical way to address these things using the existing technology.
And I'd just like to stress, it's very reactive. It's also very static. So a lot of the things that are identified, Surash said, IP address, keywords, specific things after the fact are identified. They're blocked, but that's very limited as fraudsters obviously make changes. They either change that sender ID, they change the content of the message, but that's some of the ways of combating it now that are limited because it's very static, it's very manual.
So you have the kind of static, kind of brute force approach of firewalls and so on. What is there evidence that kind of legitimate traffic is being blocked that way as well?
Yeah, we've seen that. As we've started to come into the market and we compare ourselves to some of the tools that are out there, we've certainly seen what we term as false positives. So this is where things have been blocked. There's been genuine traffic. I think there's been instances that I've heard about in the US where some major traffic, some very large consumer brands have been stopped because a particular firewall or a filter has reacted very badly and then just blocked everything. And the other thing that we notice that malicious actors have started to figure out just how these technologies work, and where things like velocity imbalances have been factors and configurable factors in some of the existing technologies. Malicious actors have started to recognize that staying below the radar and working out how they can smooth out some of their messaging flows, it means that it's become a much more complicated picture.
Right. We refer to it as bad actors. You may have a good actor, a large consumer that's delivering traffic properly, but one or two people have managed to come in on that channel and get all of the traffic blocked. So again, you block the fraud, but you're blocking good traffic as well, reinforcing that false positive statement.
So we come on to machine learning and NLP as a relatively new approach to addressing this issue. Before we sort of dig into how it applies to this area in particular, maybe we could just take a look at what NLP and machine learning is, and how it offers a sort of method of defense.
Yep. So if you imagine the world that we're living in today, we're producing more and more and more data. I read a report that said there's something like 44 zettabytes of data that's going to be created by 2020. To give you some sense of that, I think a zettabyte is a trillion gigabytes. So it's an enormous amount of data. And whenever data is being produced, the idea is, well, how do we start to analyze that data, understand that data, try and find some value in that. And as with messaging and some of the fraud that we've talked about there, the size of a problem becomes so complicated that we need another way of being able to analyze the data in order to make some sense of it. And that's where we've really taken this approach of doing, natural language processing, which is a means of, looking at the data that you have and then trying to find ways, mechanisms to start to try to understand that data, see trends, see relationships in that data. So it's a field that's probably been going for, a good few kind of 15, 20 years now or more. And it's now been applied more and more to some of the business issues that we have today. And we can talk a bit more about that.
So essentially it's a machine that's kind of teaches itself. Is that a good way of putting it?
Yeah, I mean, if we go to the slide that we have, it talks to machine learning, and I can walk you through a little bit of it. Yeah. So essentially, what you do is you have a training data set, and it's assisted machine learning. So you take a training data set and you teach the model. And you look for what's called generalization. So that's how good is your model at being able to spot particular trends. But whilst you do that, the key thing about these machine learning models is that you've got to start with unbiased training data. So that means that when this machine is looking for a particular trend or insight, it's only going to do that based upon the data it's given. So if you give it data that's particularly skewed in one way, it's going to come up with that particular conclusion. And that's what we call overfitting. So this is when you overtrain the model too much. So you give it so much data that's biased in a particular way that it gives you the answer that you're expecting. But the problem with that is what we call recall. So you have to balance that. And recall means that what we do is we have to look at the data and then we have to work out, is these instances that I haven't seen before? And did I detect those instances? So you're constantly playing this battle of recall versus precision, which is what you see on the slide there, the two metrics of a machine learning model. And to drive that home, I'll give you an example. Something like the pharmaceutical industry. In the pharmaceutical industry, what these guys will be, super concerned about is, let's say, things like lawsuits. So for them, they will want as large a recall as possible because they want to consider all of the possible ways in which something could be affecting their consumers. Whereas in the financial services, they'll probably be looking for a much higher precision because they'll want something that's super accurate, to tell them exactly when there's an instance occurring with a very high level of probability. So as we look at different sectors, as we start to think about machine learning, you try to balance some of these things. But right now, what we're doing is we're taking a model that looks at both of these things in parallel. And if you said before about these kind of false positives, you'll see that there in the pink. That's where your model has been trained to look for a particular type of thing, and then it captures what you think could be good traffic within that. So what you continually do with machine learning is you're continually looking at the model, you're looking at these metrics of precision and recall, and then you're taking new data to train the model to make it more and more effective. So this is very much an iterative process, but the key to this is having really good data to train your model. And what we would typically do is in a normal environment is whenever we get new customers is we'll look at their particular data, their traffic, and we tune the model according to what that particular customer needs.
So would it be possible to sort of walk through this slide and apply it to the messaging space?
Yeah. So I think I'd probably do that in the next slide, which talks a little bit about context, and I talk about what the process flow that actually happens there is. So you can see here, we get some training data from the customer, and what we'll do is first we'll look for particular trends or what we call clusters in that training data, and we look for data messages that look very, very similar. The example I'll give here is, let's say we're looking at a number of messages from a client, and we're trying to understand what kind of traffic is actually being sent here. Is it two-factor authentication? Is it marketing alerts? Is it delivery notification? So we'll look for messages that cluster together. And as you can appreciate, if you have a stream that includes A to P and P to P messages, then the person-to-person messages generally don't cluster because they're so variable in nature. But if a large brand is sending millions and millions of messages out, all clustered together as a particular type. So you get these clusters, and then what we do is, because as you can appreciate, we'll try and do this in different languages too, we'll look for some way of identifying what those clusters are. So I can say, and we have human labelers that do this, and these people look at the cluster and say, yep, that cluster is a two-factor authentication. That cluster is notification alerts for drivers. That is an appointment reminder. And we'll put the messages into those clusters. And then we'll train the model according to that. But what we do, the training doesn't just stop there, because as you can appreciate with natural language processing, especially when we're thinking about potential bad actors, we have a model that works at different levels. So we look at the characters within the words, and this obviously helps you identify when someone is writing win, W-I-N versus W1N. So you look at the character level, so there's a character level vector. Then you look at the word level, so you look at the word in that sequence of words in a sentence. And then on top of that, what we do is we look at what we call the metadata. And that metadata is, where did it come from? Where's it going to? What's the volumetrics? What kind of responses is that message getting? And you roll all of these three things together, and then you increase the accuracy of your model. And then what you do is you train the model with that. You'll have another piece of data that you kept behind, which will be your validation data, and then you roll that through the model to see how good your model is. And then when you make your model live, you're continually checking, as we said before, looking for the false positives and the false negatives to try and work out, did we miss something? Is there something new happening that we haven't seen before? Is there a new cluster that we need to identify? And this thing just gets smarter and smarter and smarter as we go.
And is this done on a kind of operator level, or do you crunch this data globally in order to detect patterns that will benefit the whole industry, or is it just done per customer?
It's done. We have models that are trained at a market level. So market level for, let's say, the USA or for the UK. And then what will happen is, particular customers may have a slightly different set of traffic. So you might find, more reseller traffic with one organization or more enterprise traffic with another organization. And so there'll be different types then, and you might tune the model then according to that particular customer's needs.
And have you got any examples of the kind of, character level, word level, detection and progress that's been made?
I mean, at a broad level, we typically, you can imagine we do things like bake-off versus traditional technology. We'll typically see a kind of a 15% improvement. We'll see a lot more what we call true positive versus other things, other technologies that customers have had before. And so we see that kind of improvement. In terms of some specifics, I guess I'll look to Chris. I mean, in terms of some of the things that you may have seen in the traffic that we've done.
Sure. Now, what I've seen, coming through our platform is historically we've been looking at very simply spam. And spam is a tough word to define. What is spam? It's unwanted messaging. So as back to your question about rules being applied at the operator level versus the market level, the traffic that's flowing through there when we're using anti-spam in a, we'll call it the traditional manner, it was one or the other. It was literally black and white. Now we're able to look at it differently, categorize differently, identify either true spam or unwanted messaging, setting up the rules, as per the destination, customer. And it's not just the MNO. This can be done from an enterprise level as well to protect their network. Back to the idea of the enterprise would be very interested in understanding a bad actor that's going to impact their entire messaging flow. So again, the rule sets can be, catered and tuned as granular as need be, down to the entity level, not just the MNO level.
And just to clarify, from Syniverse's point of view, you're a customer of Context, you're an intermediary. How do you, just so the audience can understand how you fit in with the
So we obviously are an intercarrier vendor and an aggregator, depending on place from a messaging perspective. We are a Context customer for purposes of managing all of our traffic through our networks.
And when was Context launched, and what kind of level of implementation has there been so far, Surash?
So Context was launched to the market in November 2017. We're now in the middle of 2019. We've got customer implementations in 5 continents. So certainly we have implementations in Europe, in the US, in Asia, and then we have organizations like Syniverse who are using it for some of their operator traffic. We have aggregator customers who are using it as well. So we've seen a really good reception to what we're offering to the market. And I think, the partly the way that we've been going into this is we're saying, as we said before, we've got this ability now to use machine learning to tackle this problem of fraud and smishing and spam and those kinds of activities. And we start off at that level saying, look, we can do this in a much more proactive way. We can spot the bad actors faster, and then this machine will learn. So it's helping organizations increase the volume of traffic that they can carry, but do it in a safe way and do it in a way that doesn't require a very large additional resource to be used to look after this. So it's much more automated as well. And those are the kind of things that we're finding resonate with the organizations that we're targeting. And then on top of that, and I know we're going to talk to this, we have this idea of being able to help organizations understand the types of traffic they're carrying. And this is where I think Context is really going to be able to help organizations understand their traffic, and that will help them think about how we can create new monetization cases with that insight.
So before we move on to that, because that is obviously a very exciting area, just maybe you can sort of wrap up with, in terms of the combating, bad practice. Where have you seen the most progress with Context so far? Which sectors of the market? Which kinds of spam?
So if I think about where we're seeing the most effectiveness, I guess there's probably a couple of areas there. One area that is particularly important is being able to spot bad actors that are trying to look legitimate. So what happens is that Context will, as we said, cluster together messages that look similar. So if you see, and let's say it's banking notifications coming from a particular, in a particular country, they'll all cluster together. And then what the customer is able to do is able to look at the root. So where do all of these things come from? And then from that, you'll be able to identify, these are legitimate senders that I know. And here's messages that look like the other stuff, but it's coming from places that I don't automatically recognize, or I wouldn't think is coming from those sources. So that's the kind of area and the kind of fraud that this is, Context is particularly good at solving those problems very, very quickly. And the other areas that I think we've seen a lot of effectiveness at is when it comes to being able to quickly add new insights to the model. So for instance, at different seasons, we'll find that there's slightly different messages coming from spammers, and the machine is very quick at being able to spot those new bad actors. I don't know if there's any specific things that you've seen.
I can give a specific example. Excuse me. Using Context, we're able to identify, fraud activity going into an MNO. Part of the message content was actually a URL, which 9 times out of 10 is considered spam, but the URL actually happened to be the MNO's URL. It was being improperly used, but it got through because at first glance, you would expect that that's passed, but the ability to have the extra metadata, looking at it to see whether source, be it an entity, be it the actual sender ID, we were able to quickly identify and start blocking that traffic, or provide the input to the MNO to say, is this truly what you should be sending, to give them the ability to block the traffic, because we now have that extra visibility.
Right. Okay, so in terms of building the market, because obviously there's the second great benefit of this approach is segmentation and differential pricing, classification, and so on. So Surash, maybe you just introduce us to the kind of opportunities that are available now.
Yep. So I think if we look at the slide on the categorization there, so what we're able to do with the machine learning, like I said, is to roll data through it, and then different types of messages will cluster together. Here's an example on this slide of a number of categories that we've seen as we looked at a particular client's data. And as you can see from that, you can get quite a lot of visibility into the types of traffic that are being sent. And that gives an organization the ability to start thinking about, oh, you know what, is any of this traffic more valuable to the sender than other types of traffic? And then that gives the transporting organization potentially the opportunity to charge for different types of traffic at different rates. And at the very least, to be able to route different types of messages, perhaps to give a lower transit time for two-factor authentication versus general promotional messages, and therefore to plan resources, because lots of organizations I've talked to have got very expensive international routes, domestic routes, and the ability to be able to plan some of this traffic gives the ability to be able to manage those resources more effectively. But then on top of that, there's probably a couple of different angles of use cases that I've seen. With some operators, it's trying to understand, I'm getting some A to P messages on my P to P routes. And clearly that means that there is some malicious or possibly unintended, but certainly fraudulent activity that's happening there. So the ability to be able to spot that and make sure that that's stopped and then rerouted into the routes that enable that to be monetized. Another example of that would be with some operators I've seen as they change their tariffing. Previously there'd been no differential between international and domestic tariffs. And as they start to introduce international tariffs, the ability to be able to spot the international from the domestic, and again, make sure this stuff operates in the same way. And as we roll forward, and I know we're going to talk about RCS as well, the ability for an organization to really understand the types of traffic it has today and the impact of RCS on that traffic. So how much of this stuff is likely to move onto new customer journeys, how much is likely to stay, and then being able to plan accordingly. And these are some of the things I think that classification area will certainly help with.
Yeah, I would say take it to the next level. And if you want to go to the next slide, what these types of solutions provide is better clarity and control over messaging traffic. Today, kind of the chart on the bottom, it shows traffic comes in through a single pipe. You rely on the upstream entity to separate out that traffic. With context, with machine learning, with artificial intelligence, you actually can provide a different level of granularity to provide, again, that clarity, which allows, in this case, the MNO, but any entity really to make different decisions, intelligent routing, as Surash said, the different monetization levels. You're able to make a decision against it, be it on your P2P channel, your A to P channel, if it's coming in through an SS7 gray route, you're now seeing it, those paths, I won't say become irrelevant anymore, but you can identify the traffic and continue to monetize it the way you would if it was coming through the appropriate path. So again, the intent really here is provide that control over the messaging traffic as it flows through the entire ecosystem.
And is this a theoretical idea, or are there actually customers benefiting from this kind of classification and differential pricing right now?
So we have customers live looking at the different categorizations and starting to make those decisions based on the results of the tool. That's live in the market today.
And what's your sense of the areas that they're most focused on, Chris?
Right now, they're most focused on basically the content classification inside of A to P to make a decision from a velocity standpoint. Should they allow it? Which channel it's flowing across? That's really where they're focused right now. Is they want to ensure that the A to P traffic is flowing across an A to P channel. And once they're comfortable there, we see the broadening of the classification inside of A to P to make a different determination against multiple price points.
And what about the brands and the enterprises? How are they responding to the possibility of different tiers of messaging priced differently or processed more quickly than others? Is that great, or are some of them worried about it?
So two answers to that. From a technical perspective, most of them are embracing this. The ability to identify that important traffic, the time-sensitive traffic, and ensure that it's delivered in a timely fashion versus something that's a little less timely and potentially paying differently for that. There's excitement there. Now, the multiple price points, there's excitement depending on what those tiers look like. But again, guaranteeing that time-sensitive traffic goes through, that's a valuable service that can be posed back onto the enterprise customers.
And are the operators starting to devise new pricing schemes now to prepare for this, or is this kind of like too early for that?
So the U.S., the market, they've started going this direction. The tiered pricing, not so much, but the idea of classification to put different rules in place against the various categories, yes.
And Surash, what do you think is the sort of potential market upside here? How much extra revenue is out there to be gained?
Mm-hmm. I think if I think about Nick Lane's Mobile Squared report, the volume of A2P messages is going to be north of, I think it was like 27 billion or something like that in terms of revenue as we head towards 2023, I think. So the market for A2P is definitely going up. I think our job as an industry is twofold. One is to increase consumer confidence in this as a messaging channel, and I think we're all doing that with the tools that we're using to stop spam, to stop smishing. And a good example of that is the work that we've been doing with the Mobile Ecosystem Forum in the UK with UK Finance to help try and stop smishing by using some identifiers around the sender IDs, and context helps takes that idea even further. The other side of things is we are going to see this growth in the US is tackling that with this idea of 10DLC, right. Where they're creating a new pricing regime for A2P messages, but using long codes. And context in that area, I think, is going to help a lot of organizations with things like compliance, making sure that the type of traffic that you've signed up for is the type of traffic being sent. And as we get more and more into the long tail of messages, we want more and more people to use messages. That's what we're all trying to do. But we also want to make it so that the easier we make it for organizations to get into messaging, the easier we make it for potential bad actors to get into it as well. So we need these mechanisms to grow the market, but grow the market safely, and then provide the insights that are valuable for the brands to provide the best customer service they can. Because as we said before, it's all about the customer at the end of this value chain, and that customer, typically in reports I've seen, is looking for an answer to their question or their query within 10 minutes. And that's what's driving this need for more and more sophisticated customer journey. So I think, a combination of a better quality of traffic, more insight into the traffic, and then giving people in the value chain the ability to optimize their costs means it will create a much more effective messaging ecosystem going forward.
And what's involved in applying NLP to your messages? I mean, can this be set up quickly? Is it done on a kind of software as a service type basis, or is there a lot of technical integration to do? Maybe you give us an insight. Sure.
I think it depends upon where you sit in the value chain and your appetite around information security and compliance. With the large operators, as you can appreciate, and organizations like Syniverse, who we're pleased to be joining us today, very, very sophisticated security policies, and what we have to do there, we have to implement within the client's environment. So the whole thing can be hosted in the client's private data centers or on their private hardware. But the service can also be run as a software as a service as well. And there, what we're very deliberately doing is designing in compliance. So, data compliance, GDPR compliance, put in the data where it needs to be in a very compliant format, in the regions that it needs to be, making sure that the right people and only the right people can access that data as we design our playbooks, our Ansible play scripts for organizations to deploy in their own environment, making sure that those configurations don't allow for any particular vulnerabilities. So a lot of thought goes into that by design.
And you mentioned RCS earlier. How does this process apply to RCS? What kind of benefits could it deliver that may be over and above what it can do for SMS? And also, can it be applied to OTT messaging for any CPaaS aggregators that are working with the OTTs? Can it apply there as well?
I mean, we're certainly, and both of those things, we're certainly talking to OTT vendors, and the ability to roll this kind of capability into that, I think is very strong. And it's, with the OTT vendors, these guys in particular are trying to make sure that their traffic is compliant and good, and the operators see it in a way that is contributing to the value chain. So I think that it's a valuable tool there. And then from an RCS perspective, I remember there was a Gartner report that they do on with CMOs and marketing directors. And one of the things that struck me in that report, 87% of CMOs are creating more consumer personalization in terms of offers or customer journeys. And naturally, things like messaging, RCS will be the tool that they'll use to do those things. And as we think about the classification capabilities of context, that's where the ability to be able to personalize these things and track how these things are going and make sure that these things are still safe. I think those are the areas that this kind of insight will bring value to those new customer journeys.
Yeah, and I would just say it's the evolution of messaging. We started talking about, what is mobile messaging? Why is it critical? RCS is an evolution of that. So tools that we're building now that support SMS need to support RCS. So it's a logical progression. The same challenges will exist. It's just a different medium. Same with the OTT channels. There's absolutely an opportunity to deliver similar services there because fraudsters don't care about channel. They're looking about how they can get into it. So these are all valuable tools, regardless of the actual messaging medium.
Right. Okay. Well, we've just got a few more minutes to go, and we've got a couple of questions from the audience. We have a question which is, how many data sets or messages do you need to analyze before you can see an improvement over a non-AI, traditional firewall approach?
That's an interesting question. In terms of a data set, obviously, as much as possible. The more data you have, the more your model will be unbiased. In terms of, how much more do you need? I would always go back to this point, that we talked about earlier. It's about your speed of reaction. And if you have a well-trained model, it will react really quickly to new actors in the value chain that might be trying to come in and do something malicious.
And another question asked about subscriber privacy, given that these messages are all being inspected. You did mention sort of GDPR and sort of compliance considerations earlier, but maybe you can just expand a bit on that.
One of the key things that we've had to do with context is really think about data policy, information privacy, GDPR, and as we provide our services and our software to organizations to run within their private environment, they need to be certain that the technology we're providing isn't going to add to their vulnerabilities. So I answer in two ways. One is that the infrastructure sits within our client's organization, so it has all of the physical and the virtual securities associated with being in their environment. And then the second part of that is around data privacy and data policy for customer information. And again, we have to be adherent to how the organization manages their data. So no data needs to leave the client's organization in order to fulfill this process. And it's all managed within the existing structure that the client has. And so we do think about these things. And then obviously the client will be thinking about, the regional aspects of that and keeping the European data inside Europe and, making sure you have the right protection for the American data. And what we're seeing increasingly around the world is organizations are looking at GDPR, and that's almost become the template for privacy around the world.
Right, and just to add that, one of the large benefits of this is the actual machine learning and AI aspect of it. There is far less human interaction, and that is a key element for any GDPR, TCPA, any of the various security protocols is you want less human interaction. There's not a human opening and inspecting that. Right. There's anonymization of data, depending on the region, such that when you do see the pieces of content, so you can label the cluster, you can't identify that PII behind that individual message.
And on a similar vein, actually, we've got another question. We talked about OTT providers and how this could apply there. Many of them have end-to-end encryption. So would the solution still work?
So I think it's there's two things there. The end-to-end encryption from a P2P perspective is definitely in there, and that's an area that from our perspective we wouldn't necessarily see that. As it comes into more the business side of things, that's where some of these things are much more open to both attack from fraudulent actors, but also the ability for brands to be able to control a bit more about the kinds of messages being sent. And that's where we feel that there's definitely a part to play. I mean, we're seeing natural language processing being applied to different sectors like, customer service, customer recruitment. These are some of the really big areas for NLP. And so, those areas concepts can apply as well.
Great. Okay. Well, we've come to about 45 minutes. Very interesting conversation. Very interesting area, and which we'll watch with a lot of attention over the next year or two. So with that, I'll thank Surash and Chris for their contributions. I'll remind you that to look out for your emails to see when a recording becomes available, and the slide deck as well, and also check out the MEF site. And so until next time, thanks for watching, and see you soon. Thanks. Bye-bye.
Thank you. Thank you.